Now what we're going to be doing is calculating mean, median, and mode, standard deviation and sample standard deviation from group data. Hopefully at this point in time you have already done these calculations from original data. Group data is frequency table, like this example right here. So what we need to do is realize that the data itself is in these intervals. So the first step is we need to actually get our midpoint. Now there are 8 numbers that are greater than or equal to 0, less than 10. We actually don't know what those numbers are. So our best guess is simply the midpoint, which in this case is going to be 5. And then midpoint to the next interval, 15, 25, 35, 45, and 55. Which means because there's been some data reduction, right, there's loss of detail, we don't really know what the numbers are, these actually will be approximate, but they should be, it's the best approximation we can do. Once we have the midpoints, then that's something that we can plug into our calculators. And you'll notice I already put L1 and L2, so I like to label these to keep them straight. I put frequencies in L1, midpoints in L2. We can actually look at this data. It's always nice to see what you're doing. Let's do a histogram. Now, this is where we have to be careful with this X list and frequency. The X list is our data, which is in fact L2. Right, so we have to come down and plug L2 in there. Our frequencies are in L1. And then if we, well, let's check our window. Oop. There we go. Now let's check our window. So our X's go up to 55, so we're going to need to maybe go up to, let's go up to 75. X scale, let's just go by 2s. The Y's are the frequencies. Frequencies go up to 32. I'm going to go up to 40 just to give it a little space. And of course I was a little quick. X scale is actually very important here. X scale is the interval, so X scale actually has to be 10, and we actually do need to start at 0, right, or negative 10, I suppose. Give it a little space also. So interval is 10, and now it's going to match this frequency table. We can hit graph, and we see we have a right skewed distribution. Our mean should be probably somewhere in here. Now, let's actually do the calculations. If we want to find the mean, that's often the first thing to do, we need to add up the number of numbers, or add up all the data and divide by the number of numbers. The question is, well, how much data do we have here? Well, if we have 8 in this interval, 32 in this interval, 20 in this interval, and so on, if we were to add up L1, that gives us how much data we have. So I'm going to go to my list and my math menu, and over here we have sum. And I'm going to sum L1, which are my frequencies. And it turns out there are 93 data points. Now, this is very important. A common mistake is to say, well, here's my data. Looks like we have 6 data points. Well, no, we actually have 93. A good visualization is to say, well, how many 5s are there? There are 8 of them. And you can almost think of the original data set with this list of 5s, and there are 8 of those. And then the 15s come next, and there are a bunch of those. And in fact, there are 32 of those. And then come the 25s. And there are 20 of those. So you can see this original data list, goes on, and there are 93 data points. So what that means is when we want to add up all of the data, we don't add just these 6 numbers. We can't, because there are 93 numbers. So we have to add them in groups. What we're going to do is add up all the 5s. Well, how many of them are there? There are 8 5s. So we could just do 8 times 5, right? And that's going to be, 40. And then there are 32 15s. So we can do 32 times 15, which turns out to be 480. Right now, we can do this in our calculators, and it's going to make it much easier. So what I'm going to do is go over to L3 and say, well, what I'm really doing here is I'm multiplying L1 times L2. I'm multiplying the 8 times 5, the 32 times 15. So in L3, I'm going to do L1 times L2. And over my calculator, notice I go up to the heading, and I can go L1 times L2. Notice that's in the edit bar. Hit enter, and it fills it in nicely. And I just filled them into L3 on my page over here. So now these are all the groups. Notice the 40 and the 480, 40 and 480. Right, all the 25 added up, all the 35s added up are 560. So if we were to add up this L3, that would be adding all 93 of my data points. So I can add up L3, and I get 2395. Now, it's a fairly simple thing to get my mean, which would be 2,395 divided by 93. All right, which turns out to be 25.75. So that's the mean. Now, if we want the median, that's a little more interesting, because the first thing we need, of course, let me do this over here. We need the median position. And we know the position is going to be the number of data divided by 2. So this turns out to be 46.5, which means we always go up, and that's going to be the 47th position. Well, or the 47th number. Well, how do we figure out, given this table form, what the, or where the 47th number is? Well, if we think about it, the last of the 5s is the 8th number. The last of the 15s would be 8, then we add another 32, so that's going to be the 40th number. The last of the 25s is going to be the 60th number. So clearly, if we're looking for the 47th number, it's going to be beyond the last 15, and it's going to be in the 25s somewhere. Now again, we can do this in the calculator pretty nicely, and I can show you in L4. What we're going to do is what's called the cumulative summation of the frequencies, or L1. So we can go to the list menu, and under ops, the 6th one is this cum sum, or cumulative summation. And we can do, except I should be in L4. Now I can do second list, ops, number 6 is cum sum, and now see that I'm in the list equation, and I can do that for L1, which is my frequencies, and you can see 8, 40, 60, just like that. It's 8, 40, 60. It cumulatively adds all the numbers in L1. And so you end up generating, this list just like this. And, this is the last of the 5s. Last of the 5s. This is the last of the 15s. All right. This is the last of the 25s, and so on. And so no matter where your median position is, you can figure out what number is in that position by doing this cumulative summation. And it turns out, as we said before, that of course here, looking for the 47th, we go past the 40th, so it has to be in this 25. So the median is going to be equal to 25. And the mode, of course, that one's the easiest from a frequency table, because it's the most frequent. All right, well, you look down the frequencies. All right, mode has to be 32, which is the 15. All right, so we have mode, of course, is 15. That one you can do just by visually inspecting the frequency table. So now what we're going to be doing is standard and sample standard deviation. To do that, I'm going to actually clear out this median and mode and this L4. I'm going to reuse L4. So now, if we want to get the standard deviation, of course, what we need to do is get the individual deviations for each data point. Like the 5s deviate from the mean, which is 25.75, by how much? And 15 deviates by how much? And of course, the standard deviation squares those differences, those deviations. So we have our mean. So and let me write out, I guess, the equation. We have standard deviation is the square root, the sum of the mean minus the data squared over n. Of course, sample standard deviation would be n minus 1. So this numerator part is going to be right up here. So we're going to enter 25.75 minus our data, which is in L2. And we're going to square it. And so we come over here. I'm going to put this in L4. I'm going to overwrite it. So here, with the parentheses, 25.75 minus L2 squared. And we get all of those squared deviations. So here we have all of the squared deviations. But again, you have to remember there are only 6 numbers in here. Are there only 6 deviations? No. There have to be 93 deviations. This sum refers to all 93. So just like what we did for the mean, where we had to add up the different groups, we're going to do the exact same thing here. So we're actually going to need L5, in which we take L4, the deviations, and multiply by the frequencies, which is L1. So over here in L5, we're going to go L4 times L1. And there we have all the grouped deviations. And there we have all of the grouped deviations. Now what we need to do is sum L5, which we can do quickly with our sum function. And that gets us 1724.7.31, this number is the sum of all the squared deviations. So we can put that number in our standard deviation formula. There are 93 of them, and this would be 13.62 for our standard deviation. Sample standard deviation would be pretty straightforward. It's the same sum on the top, just divide by n minus 1, so you divide by 92 instead of 93, and you end up with 1369 in a slightly larger number, as is typical for standard and sample standard deviation. So that is how you calculate standard deviation and sample standard deviation from group data, frequency table, as well as mean, median, and mode.